Let's have a look at the proof of Pythagoras' theorem, that is a squared plus b squared equals c squared. So I've just set up the diagram here just to make it a bit easier and a bit quicker for the sake of the video. What I've done is I've drawn a large square, okay, and we'll call this square ABCD. And inside the large square, I've drawn a slightly smaller square, and I've just turned the square a little bit, and such that the vertices of the smaller square touches the edge of the larger square. And I've just called the vertices of the smaller square E, F, G, and H. So what we have is a square inside a square, okay, and we've formed some right-angled triangles, okay. So triangle AEH, EBF, FCG, and GDH. Now, I'm not going to go into the details of proving these four triangles are congruent. They are, in fact, congruent. We can quickly see if I was to make that angle alpha there's 90 degrees. Okay, this one here would be 90 minus alpha. So that when you add all three angles together, you'll get 180 degrees. Okay, and likewise, if that's 90 minus alpha, and that's 90 degrees there, this angle here would have to be alpha. Okay, and so on. So there's 90 minus alpha there, and there's alpha here, and the pattern continues, and there's alpha there as well, and there's 90 minus alpha. Okay, and you've also got HG, GF, FE, and EH equal because they are the sides of the smaller square. Okay, so I'm not going to write that proof. I think it's easy enough to see, and I'll leave that up to you to write that proof out. Okay, I might do that in a later video perhaps. All right, now let's have a look and see if we can sort of relate the areas of these triangles and the smaller square to the area of the larger square. So what I'm going to do is I'm going to use lowercase characters here to describe or to label the sides of the larger square. So I'm going to call the side of the larger square, break it up into two sort of shorter sides. AE, which is the short side of one of the triangles, let's call that A. EB, let's call that B. This will be A, this will be B. This will be A, this will be B, this will be A, and this will be B. And these would be, again, because the triangles are congruent to each other, the sides of the right angle triangles will be equivalent or would correspond to each other. Okay, and let's call the side of the side of the smaller square, let's call that C. Okay, so there's C, 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 and C. Okay, so the area of the smaller square would be C squared, in fact. Okay, so if we add the area of the smaller square with the area of the four triangles, we should then get the area of the larger square. Okay, so area of large square, okay, that's just going to be A plus B, all right, because that's the side. If you have a look at that side there, it's going to be side A plus side B. Okay, and we're going to square that because it's a square, so we want the area. So that's going to be A squared plus 2AB plus B squared. Okay, now let's have a look at the area of the four triangles. Okay, so let's call that sort of number one there. Okay. Okay, area of the four right angled triangles. Right, well, area of a triangle is half the base times the height. So we've got four of those. Okay, so 4 times half times A times B. After all four triangles are congruent, they're identical. So 4 times half times A times B, which is equal to 2AB. Okay, So, and the area of the small square is just c squared. Okay, so if I add 2 and 3 together, I should get number 1. Okay, so 1 is equal to 2 plus 3. Okay, so in other words, a squared plus 2ab plus b squared is equal to 2ab plus c squared. Notice that we have a 2ab on both sides of the equation, and that can be crossed off. So therefore, a squared plus b squared is equal to c squared. And c is the hypotenuse of the right angled triangle.